morning students. Today we are doing another experiment with the meter bridge. This is to prove the series and parallel combination of resistances using meter bridge. Okay, so the two resistances given are this one, which is connected over here. Okay, two resistances, and this is the resistance box from which I will take out the known resistances, and this is your galvanometer to find out the null deflection, and this is your once again the battery illuminator, the battery source, this is the pointer jockey, and this is your meter bridge. First we'll connect the positive terminal of a battery to the extreme end of the meter bridge, and the negative terminal of the battery is connected to another the end of the wire meter bridge, and then this point is connected to the galvanometer. This is this point over here, and this another point is connected to the galvanometer, another point is connected to the jockey. This is the jockey. Okay, first what we will do is we'll connect the single resistance. There are two resistances over here one, and over here one. There are two resistances. First I'll connect the first resistance over here. I am connecting first the independent one, the only single resistance one. This is the observation for X1 I am calculating. And from the resistance box, let's take out only the 20 ohm resistances. So I've taken out 20 ohm resistance, and this all of the connections should be tight. So first, when I switch on the circuit, I'll check for the galvanometer deflection. When I touch the galvanometer, the jockey on the one side, it should give me the one-sided deflection. When I touch it on the other side, it should give me the other way deflection. So yes, it is giving, so it means that my circuit is connected properly. So I have taken out the 20 resistance over here. Now let's calculate the balancing point over here. See, the balancing point is obtained over here. This is obtained at 50. So for X1, the resistance from the this box is 20 ohm, and the balancing length L1 is 50. So obviously it means what over here is also 50. So if this is 50-50, so this is 50 by 50 is 1. So that means X is equal to R. That means the unknown resistance right now connected is what? Nothing but the 20 ohm. So once again I'll take out the another resistances over here. Let's take out the 30 ohm from the box, and then calculate once again the reading. See, once again, every time just you need to check whether galvanometer is going on both the side, deflection is on the both sides. So first calculate see the null deflection right now obtained is at 39.5. So this is the value over here is 30, okay, and this is your 39.5, and 100 minus this will be over here, and then you can calculate what the X1 value, the reading for this resistance X1. So now what I will do is I'll connect X2 value. Sorry, this has to be over here. So it is for the 30 ohm. The second one is for 30 ohm. This is 39.5. Now what I will do is I'll connect this X1 to X2. It has to be connected. I connected over here. Now I should be connected with this another wire. So I connect over here. So switch on the circuit, and once again check for the galvanometer deflection. See, it is going on both the sides. That means circuit is connected properly. Now find out the So first let's calculate 20 ohm from the box, and let's see the null deflection. Yes, and it is obtained at, right now it is obtained at 49.5. So for X2, for the 20 ohm only, I am getting what, 49.5. Okay, so this means what, the balancing over here it is 50.5. so you can calculate what, or you can roughly say that your this X2 resistance is also nearly to 20, because it is the balancing point is giving nearly to the 50. So once again you can repeat the experiment. You take out the another resistance, let's say 30 over here, and then once again you calculate the null deflection. See, it's going in the both the directions. So now let's calculate the null deflection. So it is happening at 39. So right now the null deflection is obtained at 39. So for 30 ohm your balancing point is 39. Okay, so this way you can repeat the experiment for X1 and X2. Now I'll do one thing, I'll connect what, the series resistances. So that means I have now both the resistances X1 and X2 over here connected in what, series. So for series connection, just see over here, for series over here, just see, this is your one resistance and this is your another resistance. So first just make it vertical and connect one wire over here. So connect one wire over here, connect one wire over here, and then another wire is connected over here. Now see, these two wires are connected like this. So if I connect one more wire over here, so it gives me what, the complete series circuit. So there's two wires now, these resistances are connected in what, series. So you know that ideally the in series resistance gets added up directly. So from our previous calculations you see that both the resistance are nearly coming to what is say 20 and 20. So when I add them, so the total resistance becomes what in series 40. So if I take out directly 40 resistances, this is my rough calculation, remember. So if I take out my 40 ohm resistance over here, now if I try to find out the null deflection, it should give me the balancing point nearly to 50, so that the resistance is, this combination of resistance is also 40. So let's see this. See, it is showing the deflection in both the sides. So first I have taken out 40 over here. If this is also 40, as I am expecting that, you know, these two are also 20, X1 and X2 are roughly 20. So this total in series becomes 40. So 40 and 40, so balancing point should be nearly to 50. See, this is the balancing point and I am getting the balancing point at what, 50.5. So this in series I have taken out 40 ohm resistances and it is giving me 50.5 balancing point. So this means what, this is 49.5. So if you calculate, this will fall near it to 40 ohm resistance. So you can repeat the experiment, taking out one more resistance over here. Let's take out 30 ohm. See, this is 20 and this is 10. This is 30 ohm resistance. So once again I'll check the balancing point. See, the null deflection obtained right now is 57.5. So for this I am obtaining 57.5. So you can calculate the resistance once again and remember that it should come nearly to 40. So this is for the series combination. Now last I'll connect this circuit for what? Parallel combination. So how do I connect parallel combination of x1 and x2? I'll connect this way. This is x1 and this is x2. So this is the parallel combination. So how will I make the circuit over here parallel? So see over here, you know that resistances are connected between these two and these two. So if I connect two jumper over here, one jumper over here, and I connect these two over here and these two over here, it means what? Directly that these resistances are connected in what? These resistances are connected in parallel over here, this side. So I'll use a jumper. And remember, in parallel, resistances are added reciprocally, and when the resistances are identical, then in series it gets doubled, and in parallel the effective resistance becomes what? Half. So my rough calculation is that my x1 and x2 are nearly 20. So in series it became nearly to 40, but in parallel it will become nearly to 10. Yeah, so I'm connecting the jumper over here. Now you can see that I've used a jumper to connect over here. This is the jumper and this is the jumper, and these two are connected over here. So this means that this two wire resistance is now connected in what? They are connected in parallel. And as I'm expecting that it should be the 20-20, okay, in parallel combination it gives me 10 ohm resistance. So first I'll do one thing, I'll directly take out 10 ohm resistance from the resistance box. So over here 10 ohm I've taken it out, 10 ohm resistance. Now I'll find out the null point, okay. So this is 10 ohm. So I'm expecting that now in what is a parallel combination, this is resulting nearly to 10, and I've taken out 10 ohm resistance. So I'm expecting that when I try to find out the balance length, it should give me the balancing length nearly to 50 only, so that this resistance is also 10. So let's find out the deflection. It is going in both the direction. So let's find out the deflection. So see over here, it is the balancing point, okay. It is showing 0, and the balancing point right now, balancing length is 50.2. So as this is nearly to 50, okay, so 100 minus L will also be nearly to 50. So this calculation, this resistance will also be nearly to 10 only. So we have proved that when individual value we have taken out, okay, for x1 and x2 we have taken out the reading. Roughly we are getting 20 and 20 ohm. In series I'm getting nearly to 40, and in parallel nearly to 10. So this proves the series and parallel combination of resistance using meter bridge. Okay, thank you.